Good evening, all. Good evening. You're welcome to the tutorials with PharmEternity, the SchoolBoy. Today we'll take a look at physics. Physics review assignment 7. Physics review assignment 7. There are 4 questions in this review assignment 7. So we'll come out one after the other as usual and pick the 4 questions. Are they come out? Okay, sorry, we'll do it in how you came. Oh yeah, Chi will come out. We'll do it how you came. Pick one question. All right, open it. Let me see what you picked. Question number 4. All right, go. Okay, let me read either the question to you. The least possible error encountered when taking measurement with a metric rule is A, 1.0 millimeter, B, 0.5 millimeter, C, 0.2 millimeter, D, 0.1 millimeter. Explain why is 1.0 millimeter. We are listening. Speaker. You are talking to the class. Stop face the class, please. Speaker.
They give you a diagram. Then they now give you the divisions. Like maybe here is 1, here is 2, here is 3. So for you to know the least possible errors that you have to divide it by 10.
Does anybody have a metric rule here? Use metric rule to explain what you are. Okay, don't worry, I will have it here, sir. This is meter rule, so use it to explain. Let me know whether you know what you are saying. At least this one has, use this one. Explain what you mean. Fast.
Okay, for example now.
Speak out. We are speaking inside.
This one is 0 cm. Then 1, 2, 3. Then for you to know the least possible errors that maybe the distance, the diagram.
Not maybe. Look at, forget diagram. From this metric rule now, show me the possible errors. Some diagram.
The list, these small ones.
Which one?
These ones in like this after this one now. This one.
So what is the value of that small one?
The value of that small one. 0.1.
0.11.
cm.
Is that your answer?
So the options you gave us is not in cm.
Talk like scientists. What
so
next?
If you convert it
Do it now. If it's 0.1, what relationship between cm and meter and millimeter? That's what I want to hear. Not long story.
You divide it by 10.
How?
For example, you have 0.1.
One what?
1 cm.
What is the relationship between cm and millimeter? I'm not going to divide by 10. What are you saying? Convert cm to millimeter. That's what I want to. How do you do it? We are supposed to be talking things like this at this stage of this topic. That's why I'm starting like this. We are supposed to talking about this thing now at this stage. So understand where I'm coming from. That's why I'm talking to you like this, because we are supposed to be talking like things like this. So talk. What is the relation between cm and millimeter? How do you convert cm to millimeter? That's the question. I agree with you. Yes, the smallest calculation is 0.1 cm. I agree with you. Now convert cm to millimeter. That's what I want to hear from you now. How do you do? And if you don't get it, you don't get the answer because you don't know it. Oh yeah. What relationship between CM and millimeter? That's what I want to hear. Tell me first before you. How can you just do that? Meter. Oh yeah, I'm going to sit down. Meter. Meter. What is meter? Convert CM to millimeter. Chingwendo. This is what we discuss in this class over and over. It was given to you an assignment again, and you are doing this on the board. I'm disappointed. On a more serious note, just apart, I'm disappointed. For 2 months now, we're talking about this almost every week. We discuss it. Different way, different topic, different form of question. Now you cannot convert CM to millimeter. You cannot. You can't say you okay. You say you divide what by 10? You divide 1 CM by 10 and get what? Please, who can convert CM to meter for us here? Please go and sit down, please. Who can convert CM to meter for us here, please? Who? Then come here. Come to the board. You say what? Oh yeah, now she talk to you. Makes what? Then convert CM to millimeter. What is 0.11 cm in millimeter? 1 what? I'm disappointed. All right. Next person, please. Fast. Pick your question. Number what? Number 2 says, which of the following quantities are scalars? I, electrical potential. Are you listening? I, electrical potential. I, torque. I, momentum. IV, kinetic energy. Option A. I and I. Option B. I and I. Option C. I and IV only. Option D. I and IV only. I and IV. I and IV. What is talking? What is talking? Okay, force. The most important thing is that is a force. Momentum so velocity being there has made it a what? Good. Kinetic energy is scalar, yes. Potential, its potential is also scalar. Thank you very much. Right, the next person, Tamsi, come out. Come and pick your question. Pick your question here. Number 3. Okay? You didn't solve it. Okay, thank you. Michael, come out. Huh? Is that what? I said it should come out. Come out, I said come out. Don't know it. Thank you. Success, oh yeah? No, not you. So nobody knows the material here. Who? Success, come. What? I show you the diagram. Where is your own diagram? Give her your phone, Chinwe. Draw it from my phone. Open the place in your phone. Let her draw from it. So what did you do?
Actually, according to what they gave us, they said the body on the ground is acted by a force of the body. This is the body. The force of 10 minutes, this is the force. So they now say at a point P, first point P, as shown in the diagram below, what is the force needed to stop the body from moving eastward? Look at what you are looking for. You are looking for the force that will stop it. So this is what you are looking for.
How did you know that the force should be in the westerly direction? You don't know.
But it's always there.
Onya Amaria. See, Onya Amaria. You've tried, but see, there's something you are doing success that I don't really like. It won't help you. You have been doing this sometimes. You do. If I ask questions on how you can't explain it. You jump into this. Try to read diagram very well. Yes, we know that you end up forming rectangle triangle. You jump into it, wow, do 10 cos theta, boom, and good. Yeah, no, don't do like that. First of all, ask yourself a question: what is the position of that thing first? Then the force that acted on it, what direction is it coming from, and which direction is the force acting? You're doing from this thing now. It's not. Anyway, at least we have tried to resolve this. The horizontal component of this 10 Newton is okay. Who can describe the diagram well from the main diagram? Tell us how she was able to get that. She got the answer, but it's not. Had it been this is an essay question, she will not be. You need to be able to do understand diagram for as I told two of us. This is past question. That is online, domain of everywhere. True of us, once you punch a character, bam, you see it. As your phone, you see it online. So quoting this thing is not enough. That's what I'm making. If this is not an OBJ and it's not a past question, you cannot be able to, you will not be able to say where the direction is, because the answer is already there online. And you solve it and pick the one that is that is not what I'm talking about. I need someone that can actually resolve this improperly. Tell us directions of because this is a vector quantity, and the direction is also very what important. Not just the magnitude. What makes a vector is that it has what direction. So you don't need to joke with the what direction. Your concern is what direction. 5 Newton is just the what magnitude. Your concern is what direction, which direction is the force. And if you learn that part, vector will be nothing to you. Do that want to write where I am is because of you. I'm explaining this thing. Not only themselves, even though that was right jam, because had it been this not a past question, and it's truly jam question. When you get to the option, you become confused. Two of us. If you don't know if you don't know how to resolve the vectors, you become confused, because you will see to west, to east, you become confused. You won't even know where to start from. So who can do that for us? Nobody. Okay, let me do that. Before we go to the last question, let me do that. Now look up. Let me draw the main diagram first, not the rectangle triangle such as gave us here. I thought she would do all the main things, sir. Success. Why do you jump to right angle triangle? The way you jump, hey, success. You know, I jump highest. But you try, Sha.
That eastward, it was straight from the direction is east and down west. I tried to really it on the outside. I know that.
Oh yeah, Amalia. Listen, so you can learn it. Listen, okay? You have tried. Just listen. So you learn it. Pay attention, please. Please look up. Let's learn this from once and for all. All these things you are seeing here, they have already represented the north, west, and east, west direction for you. Actually, the object was somewhere here. Okay? Am I communicating? Actually, this is what happened. Somewhere here, it was acted by a force. The resultant is in this direction, okay? The resultant is in what? This direction. And that resultant is what? Is northwest, northeast, okay? And that resultant is what? 10 what? Newton. The effective force that actually move the body. But they want you to determine the force that you need to stop the body from moving what? East, west. So anything that will help make the body not to move east west will act what? This direction. Am I completing? Anything that will make it not to move this way will do what? Will act. It's not this side. Am I completing? Because it can miss it. Will act this what? Direction. Am I completing? Anything that prevents from going east will do what? West. Am I completing? Now, look at it now. You need to resolve. Remember, this is a resultant force. Now, you need to resolve the horizontal component of this force. Am I completing? If you resolve the horizontal component of this force, you get this horizontal component that is acting towards this direction. So, whatever force you will need to prevent it from acting this east must act opposite to this east. It must act towards what? This is the direction. For you to stop it from doing what? Going towards what? That was what I was expecting to say. For it to prevent it from coming towards this, if somebody throws something here towards you, and you want to prevent the ball from coming here, what do? You stand opposite two of us and do what? Kick it back. That's that, because this one is not east. But if you need to resolve the east, this has a vertical component and has what? Horizontal what component. So if you prevent it from going east, the force that will stop it must act what? Opposite. Exactly the same, equal and opposite force. The force that is pushing it this direction is 5 what? Newton. So exactly 5 Newton in opposite direction, which is west, we can stop what? Equal to or above 5 Newton. Equal to or above 5 Newton, acting opposite, is what can stop this what? Body from moving what? Eastward. Does it make sense? Does it make sense? Now, if you want any force here now that can stop this from going northward, must do what? You resolve the north component of the vertical component of this. That is this 10 sine whatever. Is it clear? If you resolve it, that force that will prevent it from going north, we must do what? Act what? Act which direction? Say it. South. Good. Must act south. And it must be equal or above the horizontal component, the vertical component of this what? Resultant force. If it is less than this force, it cannot stop it. True of force. It will be equal and also what? Opposite. Now, so that's why if you now want to resolve this thing now, you now draw your this is what so jump and went into what? Right angle triangle. So she now jump into right angle triangle. Let me now start from where she started from. Before you do this thing you must have know what you are, direction you are, the force must act. That was why after doing it, I was asking you, how do you know you are busy doing like this? You are just going like this.
I know one thing that I know seriously
but so say it's we looking at you. We'll tell you what you're doing on the board. What you're doing on the board. What?
English language is my
It's not English. Forget that. Physics doesn't require too much English.
We need to understand.
There was something I was expecting to say. Just one word. I will know that you know it. Just one word. I was just expecting you to say it will stop it. It will act. It will act. So you don't have to say act. You were doing like this. You are confused. Accept it. Stop arguments. Now, this is what? On solving this is a right angle what? Triangle. And they have already given us this angle, right? And system what? So if you bring this out now, you get that thing she did here. If you bring this thing out now, clear out these things, you get something like this. And this is the force here now. This is the force. The horizontal component that make it that will move it in towards this direction. But you need to apply equal force that will act in this what? Direction to stop it. So that's why you say, if you resolve this now, here is 5 Newton. 5 Newton, but in what direction? Direction of what? West. Because this one is acting east. To stop it, this will act what? West. That's why the answer is what? B. Any question there? Ask question if you have. So I will explain. Ask question on this. Don't keep quiet. So I will explain. Okay. Silence means that we understood what I just explained now. Okay. Next person. Who is the next? Who is the next? On a normal. Who? Okay, I think success scheme. Okay, Chinwe, come and solve the number 1. I think you are next person because success came in last. Come and solve number 1. Number 1 says, at what respective value of x, y, and z would the unit of force, the Newton, be dimensionally equivalent to m raised to power x, l raised to power y, and t raised to power z? Did you get the question? At what respective values of x, y, and z would the unit of force, the Newton, be dimensionally equivalent to m raised to power x, l raised to power y, and t raised to power z. M raised to power x, l raised to power y, t raised to power z. Yes. All right. Your time start now. What we are doing here is not a joke. If I give assignment, don't do it in the rough. Do it in that your notes. I want to see that place you are doing it. Where you are doing it, you don't know how to do it. You try, you struggle, you got the wrong answer, you became angry, you cancel. That trough means a lot. You won't understand. That thing you are doing means a lot to you. Don't do it in a rough paper. Do it in that your notes. By the time you do it and fail, if each time you open the note, you see where you are doing that thing and you are failing it. When you do it on the board, you appreciate it better. It will enter well. Please, don't tell me you saw it somewhere else and treat people with notes. Do it in your notes. Do it there. Leave it there. Let that your note be everything for you. So what did you do? Explain what you did. How did you arrive at this answer?
So according to the question, you said that we should
Speak up.
at what respective.
No, let me the question. Oh yeah. At what respective value of x, y, and z would the unit of force, the Newton, be dimensionally equivalent to m raised to power x, l raised to power y, t raised to power z?
So first of all, you find the dimension for force.
I do it now. So
Which is mass times.
So what is the dimension for force?
That's
It is dimension.
Look at it.
Is that what you got?
Yes.
Explain how you arrive at that the dimension for force.
Force is mass times acceleration.
Speak well now. Speak up now.
Force is mass times acceleration.
Okay.
And acceleration is velocity over time. Velocity is displacement over time, and displacement is so mass. Which
Okay.
is this, then length, then serious power minus 2.
Okay. Good. I agree with you. That's the dimension for force. So I continue. So how did you arrive at that answer? Continue.
How I arrived at the answer is mass is just one. Then length is just only one
One what?
length. Then
One what? One what now? You say force is one, length is one. How? One what? What do you mean by one? Explain what you wrote on the board now. You say force is mass is one, length is one. I'm confused.
like the respective
What? Respective what now? Talk.
value of x.
How are they developed? How is it developed as? Explain. Tell me how you got that S is one, Y is one. That's what I want to see.
My mass is just
I have agreed with you that this is dimension for force. I agree with you. You have explained that. Now explain how you got that S is one, Y is one, Z is one. That's what I want to hear. Oh, yeah, now. You said that you jump and said that I told you to explain it. Then you calm down and I appreciate it. I understand what you did here. Good. Tell me how you arrived at X is one, Y is one, Z is one. That's what I want. We are not the one that solved it.
I read the question.
Hey. Oh, what do you? At what respective value of x, y, and z would the unit of force, the Newton, be dimensionally equivalent to m raised to power x, l raised to power y, and t raised to power z?
Okay, look at it here. So our x is 1.
How is it 1?
Mass is only 1.
How is s 1? How is it 1? Who can explain how S is 1 there? Who can explain this thing for us, please? You can sit down. God. We've been doing law of indices here, right? Simply equate the powers. Bam! Hit it. I don't train. I train people that are sharp and smart. Hit it. You will do what? Equate the powers. It's not true. This is review. This is where we'll charge ourselves. You should up and doing and know what you are doing. No reason for any step you're taking in your calculation. Be able to express yourself that this is what you are doing. This is what you did. What I'm doing doesn't end here. You may think it's just about here. It's about your life outside here. If you can't express yourself, I don't know what you are doing. If you can't express yourself, I don't know what you are doing. Nobody knows what you are doing. Nobody knows what you have inside you. Is how you do what? Express your what? Self. Articulate your points and express yourself. Fine, you got here. What is the issue now? How did you not arrive? Simply say you do what? You equate the what? Powers. According to the law of indices, what I want is what? This is equal to this, the base will go, S becomes what? 1. I want to hear it. These things are linked up in one way or the other. They are linked. Don't tell me S is 1. No, it's wrong. I won't take it. It's wrong. Because that's not how I taught you that. When I taught you that, is that what I said? Was that what I said? I said, use the law of what? Indices. If mx, remember they said that it is equivalent. If m raised to power x, y raised to power y, and t raised to power z is equal to what? M raised to power 1, and t l raised to power what? 1, and t raised to power 2. This is what I expected to do. They said they are what? Equivalent, right? If equivalent, that means they are equal. That's what it should be. When you put it like this, you do what? You put the power. Simply say the m here. That if that means m here, m raised to power is equal to what? M what? Is power 1. And the bases are what? The same thing. So the basis will do what? Go. You equate the powers and get your answer. That's what I want to hear from her. Not M is 1, L is at this stage. We should be talking like this at this stage. This is a topic we did when. And I spend my time explaining this in this class. I think we are done with this. So the answer is what? X is equal to what? 1. B is equal to M. Y is equal to what? 1. And the Z is equal to what? -2. So the option is what? Option B. Please, I want us to wake up. We need to wake up. As in for real, wake up for real. We are still sleeping. We need to wake up. This, if you watch now, you can't say that the thing is too much. This is just four questions. We need to wake up and take this thing we are doing here seriously. Let's take it seriously. You can only work with me if you want to work. If you're truly ready to work. If you're not, the door will just not normally you just leave because you cannot stay. The fire you can't withstand it unless you are truly ready to work. You want to work and your mind is there. You take it seriously. Articulate to yourself. If you come out here, look at if you don't know what to do, follow the steps I took when I was doing this in class. If you watch, I take my time to tell you steps by step, so you understand that thing and know it. Not just about choosing options. You will know it. Not any step you take. There's one thing I want you to know about calculation. Any step you take in calculation, please try to know why you are taking what that step. Don't just assume. Don't just assume. I will share with you what helped me a lot in secondary school. During my secondary school days, if I'm reading a topic, physics, I will come to one. They will tell me that F is equal to MA. It's mean that this F is equal to force is equal to most of us. I said, do you know what it took me? I didn't just cram it like that. I didn't just memorize it. I went back to start looking for how they came to the conclusion that force is equal to what? MA. That alone took me to different textbooks trying to find out why F is equal to what? MA. Not just because they said. What I'm sharing with you now is real life. It's not a made up story. I can't use a formula if I don't know how that formula is derived. I can't use it. I must trace how they derive the formula before I will say yes. And that is affecting me even today. There are things you say, yeah, I won't take it. I want you to prove how the thing came up. That's the only time I will say yes, this is true. And if you study like that, you find out you will not be mixing up things, and you can express yourself when you are called to explain a particular word, fact. And you see yourself logically analyze things. not just about they said. No. Please, I don't want what happened today again to repeat itself. This assignment was given to you to go home. To go home and research about it. Try. See, me, I don't care if you come out here. You know what annoys me? Let me tell you the truth. What annoys me that you come out here and tell me answer. But you don't know how you can explain how the answer was. That one annoys me. I prefer it that you show me where you did that you are doing. You solve. You couldn't get it, sir. I solved it, I couldn't get it. See what I did. I appreciate that. I appreciate it more. That you show me where you are solving it, you couldn't get it. From there, I will tell you, okay, do this way. That shows that you were doing something. That's what I want to see. Not getting the answer and come out here and telling me what as if we are joking here. No. If you know the answer and you don't know the thing, don't even say it. You don't know it. In Maria, don't call the answer. You don't know it. The same thing with those in TO. Not the calculation. If any option you pick here, as far as this review is concerned, any option you pick, once you don't know why that's the answer, don't tell me the answer. You don't know it. I'm very angry if you just tell me the answer. I will laugh, be happy. I can't come and explain. You say you don't know how. Then how do you know that's the answer? It looks as if we are joking. No. I'm not too bothered about whether you got the answer or not. What I'm bothered at is what concerns me is what effort, what did you do? What did you do? Like Chance that came here now, she didn't come with where she solved it. No. Telling me I don't know annoys me. Telling me I don't know. I don't know. Sir, I solved it. See what I solved, but I couldn't reach at the particular what answer. Good. That's what I want to see. It shows you actually did something. And believe you me, do you know why I don't joke with that? Because of that effort you put. Maybe you must have put like 2 hours, 1 hour trying to solve it. You couldn't get it. Let me tell you the truth. You must have tried a lot of things. You didn't get it. By the time I start on the board to solve it, you start linking those things you are doing, and you understand it better because you did something about it. Maybe you came that F is equal to FH. You say no, but F is equal to Y with at the point because of. But when if I say F is equal to FA, you're like, okay. Was that why I couldn't get it? That will be according to you. You will appreciate it more, and you can never forget it because you actually did something there. All right, so I think we are done. Did you have any question on this review? I believe what I said now is enough for us to do better in our next review. Any question on review? In the absence of any question, let's go to what we have. Let's go to what we have in the absence of any question. All right, in our next class, we'll continue from where we stopped. Thank you very much. God bless you.